All right, so today we're going to be talking about something called congruent figures. This is the background to everything we're going to talk about for this chapter, is proving congruence. And this comes out of the first lesson in chapter 4, so lesson 4-1. Today's date is the 22nd. And so one little teeny thing we talk about in this chapter is going to be with us for the whole rest of the year. This one small idea, okay? So first off, what does it mean to have congruent figures? So two figures are congruent if, now you guys say same shape, same size because you remember the word from prior chapter, but how we're going to be talking about it is very specifically. In order for them to be the same shape, that means they have to have everything matches. To have the same size is the more important part of the congruence. They have all corresponding sides are going to be congruent, and all corresponding angles are going to be congruent. It's not enough to have congruent angles to say that they are congruent figures, and I'll give you a prime example. Okay, what kind of triangle did I just draw? Okay, equal angular. And then what is this one? I have another equiangular triangle. Now, if the angles all match up, what else match up? The sides. So on the first one, I have all these sides are congruent. Now, comparing the first shape to the second shape, are all the sides the same? And the answer is no. So this is a prime example of how if you just have all angles that match up, you don't necessarily have congruent figures. Does anyone know what we would call those two guys? Where they are the same shape, but they aren't the same size? Eloise? Regular? Not regular. Actually, both of those are considered regular because they have all the same size, all the same length for the sides, and all the same angles. Mikey? Similar. They would be similar. And they actually form a ratio, a proportion between them. And we'll get into that's another whole chapter we get to study. Okay? So, what we can take from this is if somebody says, hey, you've got two triangles are congruent. Triangle ABC is congruent to triangle DEF. The order of those letters is telling you the correspondence. So that's why I've been harping on you guys, when you're doing proofs, you got to keep the letters exactly the same orientation, because otherwise sometimes you're talking about something different. So based on this one statement, I can gather 6 pieces of information. Number 1, I know angle A would be congruent to its corresponding angle, which would be in the same position of the second triangle, in the first position there. I could say that angle A is congruent to angle D. Next, I could say angle B would be congruent to its corresponding partner, angle E, and angle C would be congruent to its corresponding partner, angle F. Okay? So that's half of what I get from that one single statement. The other statement, segment AB is congruent to segment DE. Again, AB, the first 2 letters of the left triangle, DE, the first 2 letters of the right triangle. Segment AC would be congruent to segment DF. First and third letters compared to first and third letters. Segment BC is congruent to segment EF. Last two letters compared to the last two letters. So just statements, without having to see a diagram, I know 6 pieces of facts. 6 facts of congruence. Okay? Aiden.
If you put this on a proof and you list those, would that be the given?
If you were told those two triangles are congruent, I could list any one of those with a little nickname, and we're going to say it, have it in our notes in just a minute. Corresponding parts of congruent triangles are congruent, but we nickname it down to CPCDC. Okay, so that's coming up in our notes. Yeah, because that's a lot to write. So I can name any one of those 6 based on the given here. The given is the triangles are congruent. Everything else I need to give a reason. And CPCDC, like I said, we're going to talk about in just a second, is going to come up. Okay. Now, in addition to having just a statement telling us we have congruence, we can use markings. So I'm going to give you 2 diagrams. Where the markings give away the relationships. So you're going to have to trust what I say and not what it looks like. So we've got triangle ray, and we've got triangle sun. Okay? Good. So notice I have single tick marks for ray, RA, or for segment ray, segment RA and segment SU. That's saying that those 2 sides are congruent. Okay? If I have double, so this says that segment AY and segment UN are going to be congruent. Okay? Now, it also tells me that AY and RA aren't the same. And then you might see 3 markings. So what that says is ray or segment RA and segment SN would be congruent. Okay? And then we can do the same thing with angles. Symbols you're going to see there are going to be a little arc. So that says angle R and angle S are congruent. Now here comes the trick. What would be congruent to angle A? And I'm going to use 2 arcs so that you know that it's not the same measurement as angle R. What would be congruent to him? John. Yeah, it would be angle U, because those 2 triangles are not facing the same orientation. They're actually kind of nose to nose. So they're mirror images, so to speak. And then we could use 3 arcs to show that angle Y and angle N are congruent to each other, but they're not congruent to any other shapes. So based on that, all that information, I can gather that triangle RAY would be congruent to orientation R matches with S, A matches with U, and Y matches with N. So triangle ray is congruent to triangle sun. So I can use those markings to help me find congruence too. Okay? Now this is what Aiden was talking about. Everybody ready with this? Yeah? Good? Okay. When in proofs, what reason would we get to say that those 2 angles would be congruent if I know the 2 triangles are congruent? So in proofs, when the reason is definition, oops, let me spell that out. Oh, hello if I spell it correctly. Definition of congruent triangles. So I'm going to kind of switch back on the screen for just a moment. So go back to where we said 2 figures are congruent if all the corresponding sides are congruent, all corresponding angles are congruent. If I'm talking about triangles in particular, which, by the way, this is what this whole chapter is about, is triangles, and it meets the condition that all the corresponding sides are congruent and all the corresponding angles are congruent, we could say that means that's the definition of congruent triangles. So if that's what we have, we're going to use this. CPCTC. That's a vocab word. That is corresponding parts. So there's the C and the P. Of congruent triangles. There's the C and the T. Are congruent, and that's the last C. So this is a thing that kind of drives me crazy about our book, is that it calls it CPCT, and it stops at the T. But the high school, CPCTC, because corresponding parts of congruent triangles, you need to go one step further, are congruent. So that is the same as saying, that's what the definition of congruent triangles is. You will never see anyone in a proof use definition of congruent triangles. You will see them use CPCTC. Now this only works for corresponding parts of congruent triangles are congruent. Now if you have something that's not a triangle and you have congruent parts of that, let's say quadrilateral are congruent, then you would have to write it out and say corresponding parts of congruent quadrilaterals are congruent. There is no shortcut way of saying that. It's only for triangles that we have this shortcut. Okay? All right. Yes, ma'am. This is not a postulate or a theorem. This is a definition. So, but this is how we're going to write. Instead of saying definition of congruent triangles, we write CPCTC. And that's all you have to write for me. And I know exactly what you're talking about. Okay? All right, I got one more thing. Two polygons are congruent if and only if and we've got some conditions. Vertices, can be matched up so that corresponding parts are congruent. So if you cannot get corresponding parts to be congruent, then we don't have congruent polygons. Okay? So polygons means any kind of figure, not just triangles. All right, so I'm going to give you one more diagram. I'm going to tell you some information, and your job is to determine if the two guys would be congruent. Everybody ready? Yes. Okay. Don't forget, on the test, you have all of those polygon names that you need to know for the test. So, remember? Okay. If I tell you segment BR is congruent to segment CH. If I tell you that segment BE is congruent to segment CE. If I tell you that segment RA is congruent to segment HO. If I tell you that segment AK is congruent to segment OK, do I have enough information to prove those two polygons are going to be congruent to each other? Okay. Well, how many sides do those shapes have? 5, and they're called pentagons. Okay, how many pieces of information did I give you? 4. I need 5. Is there a way to get a 5th one?
Yeah, no.
Okay. What do you think, Cassie?
Since it says that BR, CH, 2 lines, 1 line.
Congruence does not lead to parallel, so I can't jump to that conclusion. Okay. Oh, Mikey.
The one line that's missing is EK. Can I not share that line?
Voila. Sometimes, and remember I told you this guy is going to come up a lot. This is the reflexive property of congruence. This is how we're going to be able to prove things, because sometimes our two shapes have something in common. So they both get to claim that side. All right, so I've got all the corresponding sides. So what this allows me to do is say, you know what, since all the 5 sides are going to be congruent, and we could add the angle measurements in there. We could say that angle B is congruent to angle C. We could say that angle R is going to be congruent to angle H. We could say that angle A is going to be congruent to angle O. And each one of those I only could use one letter because there was only one angle coming out of them. But I can't name angle E and I can't name angle K because there's 2 angles coming out of E and there's 2 angles coming out of K. So I could say angle BEK would be, congruent to angle CEK. And I could say that angle AKE would be congruent to angle HOK. At this point, I can get to the conclusion that getting my letters B, R, C, H, let's see, R, A, H, O, A, K, O, K, E, K, which would be the same as K, E, and I could get that polygon break or pentagon break would be congruent to pentagon choke. Okay. Question, yes?
I don't see how angle AKE is congruent to angle HOK.
Oh, I think I probably I did it wrong. Sorry. It should be the OKE. That's my fault. There we go. That's better. Alrighty. That's it for today.